Hi everyone, I'm Dan Caffrey and I'm the product manager for virtual production at Foundry. And today I wanted to give a really quick introduction to Nuke Stage, a new application that we've built from the ground up to deliver on the needs of on-set teams, virtual production, and visual effects. And one of the main goals of Nuke Stage is to unify this process, bring visual effects artists back into creative control, and give them a common language to work with on-set teams to deliver the needs of the director and the creative intent of the project. Over the last number of years, we've been working with studios all over the world, developing and testing Nuke Stage in different environments. And the goal here is to ensure that the workflows and tools that we build are suitable for the on-set environment and the creative demands that a production may require. Nuke Stage itself is focused around high-resolution playback for 2D and 2.5D environments. Here we're taking EXR as the playback format and using USD for 3D geometry. Live compositing is then possible by taking the most relevant Nuke nodes, rewriting them to run in real time, which is allowing us to effectively blend the on-set environment with the physical set build, but also manage the relationship between camera and screen. Operators can then make use of the track-based sequencer, which allows them to build up the environments and stage them in time. In terms of pipeline and workflow, for 2D and 2.5D shows in particular, Nuke Stage can run from asset creation all the way through to final, with Nuke Stage then picking up the TechViz and ICVFX portions on set, where we work in real time and collaboratively with the on-set team. Having Nuke as the backbone for the production allows us to understand the asset lifecycle, but also color transforms as they have happened throughout the production. This is really valuable to ensure that the content that ends up on screen and may end up in post-production has been correctly manipulated throughout the pipeline. Nuke Stage itself is made up of 3 components. So Nuke Stage itself is our editor. That's where an artist would sit and operate from. The Stage Relay is a headless networking component and handles the connection between Nuke Stage and the Stage render nodes. The Stage render nodes themselves run on each of the machines. We can scale to clusters of any size, and we don't require any specialist hardware to run. And the typical topology for the stage, you would have Nuke Stage and the Stage Relay commonly running on the same machine, which would be your control machine. This would then distribute the renders up between the Stage render nodes before then sending that image onto the wall. So for this first example, I wanted to go from 0 to 1 and show the process of getting up and running with Nuke Stage. The goal of this first example is to develop a 360 driving scene. And to begin, I have the Nuke Stage launcher on my screen. The Nuke Stage launcher allows us to define where processes run and control the launching of processes across a larger stage. For this machine, I want to run our editor and a relay to handle the networking. I then want to add 2 render node processes. For each of the render nodes, I define the host address, which is our IP, and the port number of our listener. For the relay and editor, I can leave these blank as they're running on the local machine. Once this is defined, I can hit Launch All, which launches my 2 render processes on each of the render nodes, my relay, and my stage editor. From here, I can go to my Setup tab and my Properties panel. Everything on our network beacons, so I can very easily find my stage relay. And then I can do the same in the network panel for both of the render node processes. By selecting those and hit Add, the connection is made and I can see the network panel itself, cluster health, and how my stage is performing. And to get up and running, what I'm really doing is walking through my project graph. So here I'm working sequentially down the project graph. I've defined the networking with the relay and render nodes. And the next thing to do is define my hardware. So here I'm saying each of my render nodes are delivering a 4K resolution, which runs in borderless. After this, I need to define the physical displays. So the physical displays should match their position in reality, and this will then be aligned with our tracking system. And once that's complete, I can then define the display mapping. So the display mapping is saying which output and which render node is feeding each display. And once I make this connection, I'll see my render process go full screen and borderless. That completes the hardware step. The next thing to do is define our cameras. So I'm going to make 2 cameras, one for the inner and one for the outer. The inner camera, we can then select any number of tracking systems. For this example, I'm actually going to pick a constant position. And I'm going to move that up in Y. And the same for our outer camera. Constant position. And move that up in Y to match. And that effectively completes the process of getting up and running on the stage. We have defined all of our networking with the relay and render nodes. We've defined the output resolution and the scale of the physical displays. And then we've defined our cameras. And all of this can get packaged up and exported and imported into other project files. So we only need to run through this process once. The next thing to do is to define our content. So in my scene workspace, I'm going to go to the scene graph and I'm going to right click, add mesh, and create a USD sphere primitive. By selecting the sphere and giving it some scale, I can then right click that and create texture override, which is allowing us to effectively map texture to the sphere itself. So within our node graph, this will be immediately familiar to anyone who's very comfortable with a Nuke, but we can tab and see any number of nodes and ways that we can manipulate and work with imagery, including all of our OCIO transforms. But really what we're looking for here is the read node. That's allowing us to read an image sequence of textures and apply that to the sphere itself. Once that content is added, we'll see that update on the sphere. And once we enter play mode, we'll see the result of that on the displays itself, as well as the inner frustum of the camera and the inner frustum projection. So that's everything that we need to do to go from 0 to 1. We launched the processes on each of the render nodes. We defined our networking, our displays and outputs, our cameras, and then we loaded our content and achieved the 360 driving plate scenario. In this example, we're going to look at a different way of doing car process. Previously, we applied 360 imagery to a sphere. Here, we're directly mapping the content to the displays themselves. In this scene, I have a back, side, and ceiling section of LED. I've also applied a couple of animated light cards, which are following the lighting fixtures on the bridge. All of this is contributing interactive lighting to the stage itself. In our compositing workspace, I've broken this down into 3 node trees. One for our back wall section, one for our side, and one for our ceiling. The benefit of using the node graph here is that it allows us to work in a modular way, anticipating the brief and how the environment's going to get interacted with. The same is true for applying stage utilities like tracking markers, but also adding green screen and other effects as well. Here I also have my grade nodes. These match Nuke and allow you to work in real-time compositing and grading the image on the wall to help blend the physical and virtual worlds. These values are shared between color grading UI. So if you're more familiar with this way of working, we can begin to do things like add color temperature. So we're adding cool and warm tones throughout the footage. We also have exposure nodes as an example of different ways of manipulating an image. This allows us to use the language of imagery, working with the DOP and creatively adding content, again in real time, pushing our image up a couple of stops here. In the sequencer workspace, as mentioned, I have a couple of light cards in here that I've animated in keyframes. We can curve edit within here as well. And the process of getting content into the sequencer is finding that content within our node graph, dragging and dropping. Then I can begin to add keyframes and begin curve editing and making that content what it needs to be to contribute to the scene. Now we're looking at an example of going and shooting content for real. So we've taken a camera array, we've shot a city scene. This then comes into Nuke for a very visual effects oriented process. We're isolating buildings and projecting those onto geometry. When all of this is brought together, we have a city scene which is comprised of 3D geometry in the foreground, receiving those high resolution projections, 2.5D cards in the midground, and then 2D in the background. This means we get the most parallax where it's needed, but we're also spending our real-time budgets effectively in terms of asset optimization. We've then gone through and we've layered up various elements within the scene for fog and lightning to help the city feel more alive. When all of this is ready, we can hit our export gizmo here and send a package to Nuke Stage. Now we're back into Nuke Stage. I've imported the asset and we have a debug camera stream in the viewport here. This is giving us an indication of how much parallax we can expect from the scene, and it's really useful for pre-visualization. Everything within the scene is still editable, so I can change layout positions of our hero buildings, for example. I can also begin to show and hide different layers in the scene. So I'm going to turn on our fog layers and some lightning here for the background sky. And in the compositing graph, I can then begin to manipulate the environment. So individual elements can be modified. I can change how much they pop or appear in frame, begin to soften or brighten those cool or warm tones. Grade sky replacements, and I can begin to build up the scene with various elements. The other thing I can do is I can begin to introduce depth-based effects. So in this case, I'm enabling a depth-based defocus and grade. And if I zoom right into the plate here and toggle our defocus node, you can see that begin to apply and remove itself in real time. And this is all viewable through the camera output, which is showing us the depth map in real time coming out of the camera.
So we have all of the feedback from the display meshes and the scene content here, and we can begin to then manipulate and view our stage in different ways.